perfectly possible. Okay. One. Okay, guys. So this is perfectly possible. Okay, so you have to be aware of this. This and this, they are the same. Meaning you are just rearranging this to look like in a parallel. But the important part here is they are connected to each load, each specific load. So that means they are not exactly in parallel. So in this case, you also have to remember that we are dealing with a balanced source and balanced load. Okay, balanced source and balanced load means you will have the same magnitude for the source and also the load, same magnitude. The only thing will be difference is the phase for the source, the phase for the source. So by now you should know that the difference, the phase angle between all of these sources will be 120. So just look at this as one big circle and they are spaced out 120 degree between each other. So you have 120 three times, you will have 360. Okay, I see. This is what I'm saying just now. So this is perfectly possible. This is for the load, but also valid for your source. Okay, guys, don't be blindsided by the way it is being constructed. So you have to know what exactly you are looking at. Okay, you see, it can be put up in the shape of an inverted Y, or it can be put up in a something like almost like a parallel, but they are not. Okay, I can say all of these are parallel if the A, the B, and the C terminal, they are connected. Okay, they are connected. Then we can say that all of this load, they are in parallel. But since the terminal A, B, and C, they are not connected, they are going to their own sources, then it won't be a direct parallel. Okay, remember this, huh? You have to be careful. So this is a simple, a normal looking YY configuration. By all means, it can look like this. And then you have the load. Okay, it is perfectly possible. So since these are a balanced YY configuration, then you will have the same load. Okay, so this wire AA and BB and the CC, for now it is a short circuit, meaning there is no resistance or impedance for that wiring. Sometimes we can include the impedance for the wiring as well. So if you have that, you just have to add it up with your load impedance. You just make it into a series, so a direct addition. If you have the impedance for the wiring, this is the load impedance. You can have line impedance. Line impedance means the resistance or the impedance for the wiring, because obviously the wires, they are made of materials, so they may have some resistance, and those resistance can be projected as a type of resistance or impedance. Unit ohm, OHM, the omega. Okay, so you have to also remember that for the YY system, the line current is similar to your phase current. Line current is similar to your phase current. So this is your line current. the current that has been drawn from the source, the phase current will be over here. The capital AN, CN, and BN. So those are the phase current. So in this case, if you analyze, maybe using the nodal analysis, you will see that the IA here is similar to the IAN. So we can say that you can conclude the line current similar to your phase current. Okay. So what is it again? The phase voltages. Okay, V phase voltage measured between the neutral line and any line, or you can say that line to neutral. So in this case, you have three phase voltages. One is VAN from A to N, VBN, B to N, and VCN from VC to N. So you have three phase voltages. So the phase voltages usually taken the values of the given sources. Okay, so the source, it can be VM, V maximum. It is also can be expressed as V RMS. Okay, so it is not a problem. So what's the relationship between the VRMS and VM? VRMS is equivalent to VM over square root 2. Okay, root means square voltage, which is also the average voltage, is equivalent to V maximum over square root 2. So for the first VAN, you may have VM 0 degree, VM negative 120 degree, VCN VM positive 120 degree. So these are known as the positive sequence. Whereas for the line voltage will be measured between any two lines of the available three lines for the sources. So in this case, the line voltage could be VAB from A to B, VBC from B to C, and VCA from C to A. Okay, so that's how it works. Line voltage is from line to line, line to line. Phase voltage, line to neutral. That's how you make the difference. Okay, and how we can combine or the relationship between the phase voltage and the line voltage. It is through this formula, VAB equivalent to VAN minus VBN. Okay, you know the value for VAN and the VBN. Okay, this is the VAN and the VBM. So if you solve this, you will get to this value. So when you solve this equation, you will get this value. You may go and try, so no problem on that. So when you try to solve, you will get this value. It will be expressed in function of Vm. Okay, Vm is just a given value, so not to worry about that lah. So the VAB, the line to line voltage, or simply line voltage for VAB is square root 3 Vm 30 degree. This square root 3 is just for the 3. The Vm is outside. The square root is just for the 3. Be careful of that. VBC, you will have square root 3 Vm negative 30 degree, negative 90 degree for the phase angle, while for your VCA, square root 3 Vm 150 degree. So from this, we may observe two things that we can observe. The first thing is the magnitude of line voltage is larger than your phase voltage. Okay, again, the magnitude for your line voltage is larger than your phase voltage by the factor of square root 3. Okay, The second thing will be your line voltage will always leads your phase voltage. Okay, that's the characteristic of a YY configuration. So you may jot down this, guys. While I'm talking, you can write this one. For VBC, VCA, they're all the same. The only thing difference is the phase angle, and they will be leading your phase voltage by 30°. So this is the one. So you don't have to rush, just observe slowly so that at least you have the understanding. So just look at the VAN and the VAB. Okay. The magnitude is higher by a factor of √3 and it is leading by 30°. If we compare the phasor diagram for line voltage and the phase voltage. Okay, so if you draw the phasor diagram, this is how it looks like. You have your VAN and the VAB. It is leading by 30°. Same goes for the rest. And the thing is, our third conclusion will be between the line voltages, they are spaced out by 120, and between the phase voltages, it is also spaced out by 120°. So these numbers you have to be aware of when you are solving any problems. It should follow this for a balanced load. Always. Okay. So this is just a revision. Okay, the phase voltage had the same magnitude. Similar with your line voltage, they also will have the same magnitude. And the VR leads their V phase by 30°. Okay, this is the example that you have done. See, you see guys, this is known as the line impedance. This is the load impedance. So the impedance, there are many. You have to differentiate those. You have to know the differences. You see, this 5 minus J2 ohm, it is located between the wire small a to the big A. So this means, this indicates that the wire has its own impedance. And then between line capital A to your neutral line, this is neutral line. Okay, the neutral line is just not shown over here, but it is there. So from this line, you have the load impedance. Okay. Secondly, observe they are the same value, meaning they are saying to you that this is a balanced load. Okay, a balanced load and the balanced source. 110 volts with 120° differences between the three sources. And then thirdly, try to understand what kind of sequence is this, positive or negative. How to do that? Draw the phasor diagram with respect to each other. Then you will get the answer. So one way to solve this YY connection is by simplifying the circuit. So for this, you may just take one phase to analyze, just one phase, because you have the neutral line over here, so it can be just the one source and the line impedance with the load impedance, something like this. You see, now the neutral line is over there, but in the circuit it is not shown. But for the YY, the line for the neutral line, it is always there. Okay, so this is the single phase equivalent circuit. Okay, this is just to make your life much more easier. Okay, now from here you can know that the line impedance and the load impedance, they are in series. They are in series. So you can just add it up. Okay. And then use the Ohm's law to get your line current. IA equals to VAN over ZY. So once you solve this, so how to do this? The magnitude you divide, the angle you minus for division. Okay, that's how you do your complex number mathematically for any operation. For division, you divide the magnitude. For the angle, you just minus it. So you will get this value. So this is 6.81 negative 21.8 degree phase angle ampere. Ampere unit for current. Okay, now you know your line current. You can find the another two line currents easily by using the expression, which is the IB for line B is IA negative 120 degree, meaning the difference in angle between the two current will be 120. Okay, so you just plug in the whole value over here. So the angle you just try to plus. So negative 21.8 plus minus negative 120, you will get negative 441.8 degree. Magnitude same. You do similar for your IC. IA negative 240, or you can also put positive 120. They are just the same. Negative 240 location and the positive 120 location are the same. You can draw your phasor diagram, you can have a look. Okay, now you just plug in your IA value. Okay, just plug in your IA value 6.81 negative 21.8. You solve this, you can either get this value negative 261 or positive 98.2 degree ampere. Magnitude remains. So that will be the line voltage. Yes, sorry, line current. So if the question asks you what will be the phase current, what will be your answer? Anyone?
The phase current would be the line current with a 30
Hello?
angle on the phasor.
Your voice is very low.
Oh, can you hear me now, sir?
Again?
Can you hear me now, sir?
Okay.
The phase current should be the line current that we got with the phasor angle minus 30, right?
That will be for the voltage.
Ah,
Guys, this one, this is the first thing that I've shown. You
oh
see?
yeah, it's the same.
They are the same. Okay? They are the same. I have uploaded the tutorial at the last slide. There will be a summary table, so you can always refer to that. Okay, you see YY system, or YY configuration, or YY connection, doesn't matter what the term is. If it is a YY, phase current is similar to your line current. That's it. Because of the obvious fact that your line current which is flowing through this line are the same current flowing through this load impedance. You have the same current flowing through. Okay, if you do the nodal analysis at the node capital A, let's say you have I1, I2, I1 equals to I2, mean to say your line current here is similar to your phase current. Okay, guys, science and engineering, they are very much straightforward because many of this concept is mostly based on the established law and the logic that follows behind it. Okay, if you simply put up a nodal analysis, you will see that the current that flows through this line will be the same. Okay, so if you're in doubt, you can always do the simple analysis just to check. Okay, so for a Y-Y connection, if you manage to find your line current, that means you already have your phase current. You don't have to worry about that. Now, guys, I would like you to calculate the line voltage for this circuit. The line voltage over here. Can you do that?
The line voltage for the load part, sir? Or
Again?
for the load or for the...
The line voltage for the circuit.
Oh, okay.
The line voltage for the circuit. Line means what? From the two lines, right? A to B. B to C. And C to A. What's the formula for line voltage? Anyone? You have the notes with you, eh? Anyone? What's the formula for your line voltage?
The line voltage is equal, like E is the same, and with the modulus.
You're saying what? It's the same?
Oh, sorry, my bad. But I think it's in the slide before this.
Okay, so what's the formula? Can you tell me?
The line voltage, like the VA is equal to VB and equals to V and CA, but everyone has the magnitude, is it?
Okay, so the line voltage, let's say for VA, is equivalent to square root 3 V maximum and then the phase angle. This one, guys. Okay, this is the one. And what VM is, so you only have to find for one line voltage. You only have to find for one line voltage. The rest you just plugging the VM value. That's it. Okay. Please pay attention on this. Know the relationship, know the similarity, know the difference. Okay. Any question on this? Any question, guys? Okay.
Doctor,
Let's see. Yeah.
sorry, regarding the circuit, the neutral line can be different position for each face.
The neutral line can be positioned for each face.
Different
Okay.
position or
No. The neutral line will be always here. If I were to draw, it will be from this point where all the source meet to the point where all the loads meet. That will be your neutral line.
so one circuit only have one same neutral line lah.
Yeah, only one neutral line. This one, slide 49. This one.
Okay.
Okay.
Yes, and one more, the YY configuration can be changed to parallel in like in what condition? Like it requires us to change it.
Okay. It is not conversion, it's just the drawing. It is not conversion. We are not converting this. You cannot convert a YY connection to a parallel lines. No. It's just the way you draw. It looks like a parallel, but it is not. This one. So now, you look at this. Does this look like a parallel to you?
Yes.
Okay, but is it really a parallel circuit?
No.
No. So that's the answer. Just the way we draw is just to throw you off balance. I'm giving you hints on how we can set the question. You understand?
Okay, doctor.
Okay, you have to be careful. So I can give you another one more. Look at the Y. I can put up this in a T form. Can I do that?
T form.
I can draw this in a that looks like a shape of a T. Is that possible?
I guess yes.
Yes, you can. Yes, of course you can. Okay. Let's go back to the drawing. Okay, first I have to do this. Okay. Copy, paste. Okay. Let's say assume this is the load, okay, that you have. Okay, so this is the load that you have. You see, now I can just redraw the whole load to look like a T shape. You see, the drawing is bad, but I hope you understand. You see now, this looks like a T shape. And then I also have to draw this line. This one. Okay. So each one of them, they are going to their own source. So can we say this is a parallel circuit? Of course not. This is a YY configuration. I just simply rotate. Okay, I can do this, remove this, rotate this again. Okay, now it looks like a Y again. You see? So now it looks like a Y again. I can make into a T as well. So that's why I'm saying that it's all imagination. And luckily for you, I have a lot of imagination. That's how I do my own questions. These are the quiz questions that I did before. just drawing on my own and then trying to solve. So you have to be ready for it lah. Okay.
Okay, thank you, Doctor.
Okay. So remember again, I just want to re-stress this again. These are not in parallel. These are not in parallel, although it looks like it is in parallel. Okay. So it can deceive you. It can deceive you. You have to be very careful. Okay, second, you cannot convert this YY or Y delta or any other configuration to a parallel or series unless you do some kind of circuit conversion, which I'm not touching here. It is more related to electrical and electronics. However, what you can do is converting from Y to delta or delta to Y. That is possible between the two types of shapes, Y and delta. You can between those two. But if you want to move from anything other than Y and delta, it is not possible. It is beyond your topic. Okay. So we are done with this. So now let's move into the delta connection. Okay. So now this is how the delta connection will looks like, a triangle. It can be an inverted triangle as well. I can make this that looks like a square as well. How do I make this square? I just push this wire straight and then I have a short circuit over there. Then it will looks like a square circuit. Okay, something like this. Let's say I have this 1, 2, 3, copy. I have a new slide. Okay. So for now, this is how your delta is. Okay. This is how your delta. It's very hard to draw lah using the okay, this insert. Okay, and then we have this. Don't mind with the drawing, as long as it looks like a triangle, then it should be fine. Don't have the time to do the makeup. Insert. Okay. Okay, now this is the delta shape. This is the delta shape. So now look what happens now. Okay. I have the same one, but I'm doing something like this. Aish. This one is very difficult. Okay. Okay. More pronounced. Never mind. Okay, now I have another one. Okay, and then I have another one. Alamak. Silap. Okay, see this triangle, this is the square or rectangle, whatever it is. Are they the same? Absolutely. They are the same. Both are delta. So be very careful. Imagination, you must have imagination. Of course, that imagination must be guided lah. It's not simply you imagine something. Okay, so now you have your line voltage from line to line, VAB, VCA, VBC. Okay, that's one thing. Second, do you have a neutral line for this delta? No. The answer is no. There is no neutral line for the delta. Okay. This is for the load. Okay. A triangle. Balanced load. So you will have similar magnitude, similar phase angle. You see, it also can be drawn in a rectangle or a square shape. It is perfectly possible. So this is where you have to be really careful. You analyze the circuit carefully before you reach your conclusion. I'm just checking whether you are putting any message. Okay, so let's continue. So this is the balanced delta connection. So you can see here, there is something changing here as compared to the YY connection. For the YY connection, the line current is similar to your phase current. Phase current are those that it is flowing through your load. Okay. In this case, if you do the analysis over this node, you will see that when the line current reaches the node capital A, it is divided into two, IAB and ICA. So this shows that for the delta connection, the line current, it is not same as your phase current. Line current, it is not the same with your phase current for your delta connection. So that's the key difference that you have to be aware of. Okay, you can just simply again analyze the simple node just to get to know or to make sure what exactly is happening here. Okay, so for the delta system, instead of line current similar to your phase current, it will be now line voltage similar to your phase voltage. Okay, that's the link. Line voltage similar to your phase voltage. Remember this, guys. Make the notes. I ask you to do the mind mapping. Maybe I should make you submit your mind map to me. All of you submit your mind maps to me by this Friday before 5 p.m. I will make the, what do I call, a forum in the ULAN. Okay, when the ULAN becomes stable, I will make a forum. You post your mind map. You also can post your question over there. Let's have a discussion. Okay.
All right, sir.
Mind map here means whatever that we have learned, you are trying to put out all the information clearly and concisely. Maybe in one page, but it's up to you how you want to do it. That mind map is not for your friend to understand. It is not for me to understand. It is for you. Remember, it is for you. That's why you are doing it. It is for you. So I want to see how you are doing your mind map. Okay? Whatever that we have covered so far. Okay, come back to our lecture.
Sure, the mind
Yeah.
map will be consists of every topic we've learned.
Yes.
All right.
But for you, if you feel that will be very long, just try to do a mind map for the one single phase and the three phase.
All right, thank you.
Yeah, single phase and the three phase. Because the 2 or 3 weeks earlier lecturer, lectures week 1 to week 3, those are just physics 1, physics 2 stuff. It's not really your EPM. This is your EPM, electrical power machine. Okay, please, I'm asking this for your own good. Remember, guys, I'm not the one that's being subjected to test or quiz. Even if I make a mistake in quiz or test, I won't be penalized because I don't have marks to be given to me. Okay, it is for you guys. Please do follow this so that you can easily pass this EPM. This EPM is the very basic one, guys. Trust me when I say this to you. I have gone through far more difficult electronic circuits. Yes, and you are not even touching even let's say 1% of it. That's the truth, guys. Please, EPM is easy, so try to do this in the best possible way possible. The best way possible. Okay, so let's come back to our lecture again. For the data, remember the line voltage is similar to your phase voltage. For your YY system, YY configuration, line current is similar to your phase current. For your delta system, it will be the line voltage similar to your phase voltage. So where's the logic here? Come back to your circuit. That's it. You want to see the logic? Go back to the circuit. Now, this is your source, right? This positive minus is your source. So what's the value for your source? It will be Vm 0 degree angle. For Vb, or over here, it will be Vm negative 120 degree. For your Vc, it will be Vm positive 120 degree. That's the normal value. So if you look at the line, how it is being connected, or if you look at the definition of the line voltage, it is from one line to another line, between the two lines. So look at line A to line B. Line A to line B. So what do you see here? Your phase voltage. So your phase voltage is the line voltage. Okay, so that's the logic here. You understand? It must be clear for you. Look at your definition of your line voltage from one line to another line. So let's say line A to line B. Line A to line B. So you are seeing this. So what voltage is this? It's the phase voltage. So automatically your phase voltage is the similar to your line voltage. So that's the logic there. Okay. And then your line voltage is the voltage across your load. So you can see that they are in parallel. I mean, for just this a single phase over here, they are in parallel. Imagination, guys, try to redraw the circuit and then you will see my point. Okay, try to draw the circuit from A to big A to the big B to the small b. Draw the circle, you will see that the VAB is across your load impedance. Provided there is no impedance in the wire, if there is no line impedance. If you have a line impedance, that means your line voltage is across your line impedance plus load impedance. Okay. For your phase current, it could be obtained by using this formula, IAB equivalent to VAB over Z impedance for the load. So delta impedance. Okay. VAB, since the voltage is the same, so this will be VAB over Z, the impedance, you will get your IAB. So similar for your IBC and ICA. So follow the notation AB, BC, CA. because we are looking at the sequence. So please follow this nomenclature. Okay. And then the line current, you can get it from our previous trusted way of doing it. You may use your KCL or the nodal analysis to get your line current, which is the IA, IB, and IC. So if you look at the point A, you have IA coming in, ICA coming in, IAB coming out. So nodal analysis stating that IA is equivalent to IA plus ICA equivalent to IAB. So IA will be IAB minus ICA. Okay, IA equals to IAB minus ICA. You do for the rest of the node, you will get the corresponding equation. You already know the answer for your IAB and ICA. Plug in those values. If you solve it, you will get IA equivalent to square root 3 IAB negative 30 degree. Okay, so you will get this final expression. Let's say you don't want to do all of this. You can just memorize this. It won't change. This thing will never change for the balance load. There's no way it could change. The expression will stay the same for a balance load. That's the condition there. The asterisk for a balance load, this will be the expression. So we can take note of two things over here. Your line current is larger than your, what is this? Phase current by factor of square root 3. And it is lagging with your phase current by negative 30 degree. Lagging. Or phase current leads or line current lags phase current. Doesn't matter. For other line currents, you just have to plug in the value of IA. This whole expression, IA. Just put in there, you will get for your line current B and the C, respectively. So if you observe this carefully, okay, even though you have so many expressions, what really that you have to do is you just have to solve for one line current. You will get the rest. Solve one, you will get the rest. Okay, so this is the summary for the phase current and the line current. Please observe this carefully. Okay, know the similarity and the differences. And then for the good part, if you want to draw the phase diagram, okay, this could be always a reference point for you, a point of reference for you. See, the phase current IAB, ICA, and IBC, they are spaced out 120 degree. Okay, they are spaced out by 120 degree between each other. And then if you draw your line current, it is lagging by 30 degree, and they are also 120 to each other, IA, IC, and IB. IA, IC, IB. Okay, a very important diagram for you. Always check, guys. I will love if you can do this. IA equals to IAB, ICA, and then you plug in your IAB value, and then you solve until you got this expression. That will be good for you. The only difficulty is you don't have the real value. It is fine. You are just solving in terms of ABC, like you used to do during your additional mathematics and modern mathematics. So it's nothing changing there. Nothing changing here. The only thing is we are introducing a concept, and then we use mathematics to solve it. That's all. Okay. So for the properties of the phase current, all phase current, they have the same magnitude and they are out of phase by 120. So this is pretty much straightforward. Line currents are also the same. They must have the same magnitude. And they are out of phase with each other by 120 degree. Okay. And then the relationship between the phase current and the line current. Line current is bigger than your phase current by square root 3, and the line current lags their corresponding phase current by 30 degree. Okay, the angle for IL is IF minus 30. So that's the relationship. Okay, now maybe you can try this. Okay, I give you 5 minutes. Now this will be the 5 minute break, but while just relaxing, you can try to draw the diagram for this, and then maybe you can try to solve. Okay, guys, let's continue. I hope at least you draw the diagram. Okay, it's a positive sequence source. They just give you one source VAB, but you can pretty much do for another two. Just make the magnitude remain the same, and the angle become negative 120 and positive 120. And then you have the balance load, so you will have the three same load on your loading side. Okay, so there is no picture, never mind, we can just have a look at this picture. Okay, so you can put 330 0 degree, 330 positive 120, 330 negative 120, and this z delta will be 20 minus j 15 omega. So if you draw the diagram, this is how it should look like, delta delta. Or if you want to be fancy, you can draw in a square form. Okay, but it still remain the same. Fancy here means just your imagination. Okay, so what do they want? Calculate the phase current of the load and the line current. Okay, now for delta delta, we know that the line voltage is the same as your phase voltage. So that once you understand that, that will be out of the way. Now you just have to analyze and try to come up what will be your phase current. So first, try to get your the load impedance in the form of polar, because you are going to do the division. So if you remember, it is better it is in the polar form if you are doing the division or multiplication. Okay, now you just have to analyze one phase. You have a three phase, but the way you go about is just by analyzing a single phase. Okay, only one line, then you can solve the rest. Again, as I said earlier, you have so many expressions, but what you really have to do is just to get one current. The rest you will get. The rest easily you will get it. Okay, so in this case, let's try to analyze the VAB and the Z delta. Okay, so first you try to find your IAB. So now you have your VAB over Z delta. Okay, 330 over 25, you will get 13.2, and 0 minus negative 38.87, you will get positive 36.87 degree ampere. So this will be your phase current for IAB. So now once you got this, you don't have to do this again. You just have to take this value minus this negative 120 degree to get your IBC, and plus the angle 120 for ICA. The magnitude remains, only the angle changes. Okay, so this is a smart way of doing it lah. For your sake of understanding, you can do this slowly one by one. Okay, any question on this part, the phase current? Okay. Okay then. So again, I just want to really stress this important point. You want to find the phase current, just look for one. That's it. That one, you can use it the source with a 0 degree. It's much easier for you. If you let's say, okay, I want to be fancy, I want to do negative 120, so you will put 330 volt, negative 120. You will get the answer, but that answer is for your IBC. So you must be aware of what to do next. Okay, you must be aware of what to do next. how to get your IAB and then your ICA. How? You should remember they are 120 degree in difference. So what you have to do is you just have to plus 120, then this one minus 120 to get your ICA. If this IBC is your reference, okay, if IBC is your reference, you get this value, this is perfectly correct. Now you just have to find your IAB and ICA. So to get your IAB, magnitude remain the same. You just have to plus 120. You will get your IAB, and you minus 120, you will get your ICA. That's it. Now you got your phase current. You can move to your line current. Okay. Line current expression is IAB square root 3 negative 30 degree. So since now you have your IAB, just plug in the value. You multiply the magnitude 13.2 multiply with square root 3, you will get 22.86, and then you just plus the degree. So 36.87 plus negative 30 degree, you will get 6.87 degree. Now you got your value for your IA, one line current, that's it. Now you use the expression and then you solve for the rest. How? You will know that the line current magnitude is the same, only the angle will change. So for IB, you minus negative 120, for IC, you plus 120. So now complete. Looks tough, but it's actually simple. Okay, it's actually straightforward. So you see, to trigger all of this, okay, you just have to find the IAB. One time usage of Ohm's law, you got the value, you understand the relationship, you will get the rest. Straightforward. You don't have to put too much time on this. Again, to trigger all of this, you just have to find this one. This is the spark that you need. And this spark must be correct. Okay, this one. This is the main part here. The IAB equivalent to VAB over delta impedance. That's it. Okay, so that's why I show you the single phase first. To analyze the three phase, you use a single phase approach. Okay, now we move into the hybrid. Okay, we first cover the YY, delta delta, now Y delta. So Y delta or delta Y, just the same lah. So now you can see that here you have your Y source, and then you have delta load configuration. Okay. Okay, now let's see your understanding. Try this example. You may draw this circuit and then you put in the values. A balanced positive sequence Y connected source with 100 volt 10 degree phase angle. Okay, VAN, VAN 100 10 degree. Okay, you just write it down, draw it and write it down the values. Connected to a delta connected balance load 8.J4 ohm. So you put 8.J4 for all of these three. Now calculate the phase and line currents. Okay. I give you 3 minutes. I just want to see the concept from you. Okay. Write this value over here. Okay. And then you tell me how to solve. Draw the diagram first and then you label it. Okay, now guys. Okay, my first question is, your VAN is 110 degree. Okay, so your VAN is 110 degree. Now anyone can tell me what is your VBN? Anyone?
Hello, sir.
Sorry, your voice is too low.
Hello, sir.
Yeah,
Hear me? Okay. So,
okay.
VPN will be 100 negative 110 volt.
Okay, very good. Anyone for VCN?
130
What 130?
volt.
130 volt?
No. Wait a minute. What's the question? Wait a minute, sir.
Okay.
100 and 100 and 130 angle, 100 volt.
Okay.
Ah.
Okay. Okay. Very good. So you have to be very technical, because you are a technical person now, or you're about to be a technical person. Okay. So VCN will be 100 volt, same magnitude, but now 10 plus 120 degree. So you will have 130 degree. So that will be the source voltages around the Y configuration. Okay, now this is out of our way. Now we look into our problem here, which is the phase and line current. Now guys, anybody want to attempt and tell me how to do that? Anybody? Is Amanda here? Amanda Beatrice. You are very quiet, huh?
Oh, wait, can I try, sir?
Okay, 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 our favorite guy. Okay, come on.
For the phase current, right?
Yeah.
So for, if I'm not mistaken, the phase current here on the delta load side would be IAB, correct?
Okay.
Then in order to get that, we must get the phase voltage over the impedance Z over here.
Mm-hmm.
So based on the question, they gave us the VAN. So in order to calculate the phase voltage, we must use the formula, I believe, square root 3 times VAN angle 30.
Okay. Over.
Over the impedance.
Okay. Okay. Very good. Now, anybody has a different answer? This one just to check. Anybody have a different answer to that? You see here, guys, what your friend say just now said is the correct one. Your phase current. You need to get your line voltage and then you divide with your load impedance. You need to get your line voltage. That's why you have square root 3 multiply with your phase voltage 30 degree. And then you will get 173.240 degree over the load impedance. Now the question here is, why I'm getting the line voltage, not the phase voltage? Because you see here, for the delta, it is going from line to line A to line B, line A to line B. So you need to get the line voltage. If you put the phase voltage, you will get a wrong answer. You see, line A to line B, line A to line B. So what is line A to line B? It's a line voltage. So that's why you need to get the line voltage first. So what's the formula for your line voltage? VAB, in this case, VAB is equivalent to square root 3 VAN degree 30. So since your VAN is 110 degree, so you plug in the value 100 times square root 3, 10 plus 30, you will get 40 degree. So you will get this answer. Okay, again, I'm repeating again. Why you need the line voltage? Because you have line voltage across your load from line A to line B. You see, line A to B. So is it the phase voltage across your load impedance or the line voltage across your impedance?
It's the line voltage.
Is the line voltage. Okay, so since the line voltage is the across our load impedance, so you need to get the line voltage first. So the formula for your line voltage is VAB equivalent to square root 3 VAN degree 30. What is VAN? VAN is equivalent to 110 degree. So now after that you get all of those value, you just plug in, you will get this. Now you can get your IAB 173.240 degree over 8 plus J4. You divide, you will get this value 19.36, 13.43 ampere. Now once you get your IAB, the rest just falls automatically for your ICA and the IBC, because we already know they are 120 degree between each other for the line currents. I'm sorry, the phase currents. So for IBC, you just minus negative 120 for your angle. And then for your ICA, you just plus 120, then you will get the value. Simple. Now you got your phase current. Phase current. Phase current is over here. Okay, going through the line between the A and the B. Now to get your line current. Okay, how to get your line current? Anyone?
I believe we can get the line current from the phase current we just already obtained.
Okay, can you be a bit more specific? Is there any analysis that we can do? The nodal analysis?
Yes, there is. For example, at the capital A node, we
Okay.
can see that IAB is equivalent to IA plus ICA.
Okay. Very good. That's how you go about. Let's say you totally forgotten how to do. Don't worry. Don't worry. Just remain relaxed. Just do the simple KCL analysis, the nodal analysis over node capital A. So you will see that IA plus ICA equivalent to IAB. So IA will be IAB minus ICA. So that will be your line current. So you just do for one node. That's it. Get the line current for IA only. Okay. So now you see my kids now disturbing me. Can you hear her crying?
Yes, sir.
Really sorry about that. So what's happening here is my elder daughter is coming up and she blocked the door from the so that the little one cannot enter. So that's why she's crying because she's not allowing the little one to come over. Because if she managed to bypass this security, she will be beside me and she will be talking to you, not me. So that's the stuff lah going on. It's a struggle really. Never mind. Sorry about that. So let's continue with our lecture. So your line current IA square root 3 IAB negative 30 degree. So this is after you solve your nodal analysis, which is IA equivalent to IAB minus ICA. When you solve that, you will get this expression, or you don't have to do that, you just get the expression square root 3 IAB negative 30 degree. Now you know what is your IAB. This is the one. So you plug in, do the rest, you will get your IA. Now, do you have to repeat the whole part again? No need. Just use the understanding that your line current, they are 120 degree with each other with the same magnitude. So automatically you can get IAB equivalent to IA negative 120 and IC is IA plus 120. That's it. And then you can do the rest. So to solve this whole equation, this whole problem, you just have to get your IAB. You just have to get your phase current IAB. The rest will just come by itself. But the question is, the issue is how to get your IAB. More specific question will be how to get the right IAB. So this is where sometimes the students will make the mistakes. You see, instead of getting the line voltage, you will put the phase voltage. That's the problem there. Second, you forgot the angle, the initial angle. Sometimes we always automatically assume is 0 degree, but it can be in this form. The important part is, doesn't matter what the angle here, between the VAN, VBN, VCN, it should be 120. Doesn't matter what's the starting phase angle difference. Okay, so that's usually the two mistakes that you guys will do. The third mistake will be wrong way of dividing, the division. 172.2 over 8.8 plus J4. Okay, so you have to do this carefully. You have to be mindful of the traps here and there that you can see. Okay, so all in all, what you really have to know is the YY and the delta delta. If you understand these two concepts, you can do the hybrid, the Y delta and the delta Y, by doing the Ohm's law and the nodal analysis. Okay. Another alternative way is by doing the conversion. So this is the conversion. An example of a Y delta connection. Y delta connection. Okay. You can convert this delta load to a Y load. How? You take the one delta load, you divide by 3. Now you can redraw this whole diagram in a Y configuration, and that value will be Z delta over 3. That's it. You can do the conversion, and then now you will have the YY circuit. So if it is a YY circuit, it's easier for you to solve. It will be pretty much straightforward for you. So this will be an alternative way. Or if let's say you have a delta Y, you have a delta source and a Y load. You can do the conversion from the Y load to the delta load. How? Z delta is equivalent to 3 ZY. How do we get this expression? By doing the mathematical formula, which I'm not showing over here. Perhaps I can do a simple recording later on. Okay. Now, any question, guys? Any question?
Not really, I guess. Oh, regarding the lab, so is there anything we should know about it?
Yeah, I will go into that later.
All right.
Okay. So for no question. Okay, so please revise this. This will be covered in your test 1 next week. Okay. Now on your lab. Okay. I have added all the information in the laboratory section. Okay, and I have divided you into groups. Laboratory group 1 to 6 is 2 to 4, 7 to 12 is 4 to 6, 13 to 18, 2 to 4, and Thursday 4 to 6 will be group 19 to 23. All the groups are here, the list of groups. Lab grouping. Okay, this is the one. Group 1, example, Abdulaziz, Halif, Farhan, Muhammad Farid, and Zu Fenggan. Okay. Group 2, Afika, Hemandra, Muhammad Faris. Okay. Group 12, example, Anil, Muhammad Afif Iqmal, and Nurul Ain Natasha. Okay. This way. This is your grouping. Only group 1 have 4 people. The rest 3 people. Okay. Again, I have put the schedule. Group 1 to 6 and 7 to 12 will be today with two different timing, 2 to 4 and 4 to 6. Another 2 big groups will be on Thursday, 2 to 4, 4 to 6. Okay. Second, this is the first thing, the grouping and the schedule. I have uploaded the EPM interactive laboratory, the simulation. Everything is there, the manual and the PDF file. The manual in PDF file and the software for you to download and then install. Okay, please go through that as well. Number 3, I have created the channel. Okay, so please go correctly to that respective channel. All of you actually have the access. Okay, all of you have the access. So all of you have to go into your respective channel. Okay, now I received a request from yesterday that one of your friend has a clash. Okay, Never mind. You are still in the same group, but you will go to the lab that is suitable for you. Okay, so that you go through and experience it by yourself. Later, when you do the report, you have to do it together with your group that I have assigned to you. Example, let's say one of you have a class, you have a class at Tuesday 2 to 4. Okay, fine, no problem. Don't make any big issue out of it. You, that person, just go to 4 to 6 lab, okay, and then go and meet with your group and then do your report. You understand? Example, uh, let's say Barraj Singh. He's in group 14. So group 14 is Thursday 2 to 4. Okay. Let's say Barraj Singh here, he has another class at 2 to 4. Okay. Fine. The other two guys, you may go to your respective lab session. Barraj can go to Thursday 4 to 6, by himself. It's not a problem. Anyway, all of you are alone when you are doing this online laboratory. So the important part is you go through the process, you try to understand what they are doing, and then during the report, you three guys will come back together and then you will do the report. You understand? The report, I'm giving you a lenient timing. Submit after 2 weeks. Meaning, week 5, we are doing our first lab, synchronous machine. Okay, if you go to your lab, I will already put the title synchronous machine. You see, I also put the details. Everyone, all of you will do the synchronous machine. All of you, for all
So
4 lab sessions.
does that mean that it's one report per group?
Yes, one report per group.
Okay.
No need lah, everyone to write. Everyone contribute lah. One guy
Is it handwritten or typed?
Okay, up to you. You can handwritten it. You can type written. Anyway,
All right, thank you.
yeah. Also try to ask the GA. Okay, I think should be fine lah. Either way should be fine. Okay, that's the session. Okay, and the report you submit after 2 weeks. Okay, no need to submit immediately after. I'm just giving you some time lah to do that. Okay, currently at the current point of time, we have 2 labs, synchronous machine and asynchronous machine. Synchronous and asynchronous. Transformer, we don't have the simulation ready. So I have requested the GA to go and do the live recording. They were doing that when this forced MCO takes effect. So all of the PG students have to go through quarantine. 10 days of quarantine. So it got delayed a bit lah. But anyway, don't worry. If the third lab happens, it should be in week 5, 6, 7. It should be in week 7 or week 8. So we still got time for it lah. So for now, let's focus on the lab 1 synchronous and lab 2 asynchronous. Okay, I will tell you when will be the lab 2. Okay. Have I covered everything? Group, the GA. So who are the GA? Mugashini, Ain Afina, and Nuruzaman. The schedule, the details, and then the channels. Okay, guys, I have been very careful. I have uploaded everything. You also can find the grouping list over here. Okay, it is here as well. I hope I don't miss out anything. Any question, guys? Regarding on the lab.
I don't
Quite
think so.
clearly.
Okay. So everything straightforward, guys. So please don't mess up. Okay, now before I end the class, I want to go back to your quiz because I think the quiz was something like an electric shock to you guys. Do you agree? Or you're saying that sir, it's just a
Agree,
very
sir.
straightforward, easy question. Again, sorry.
Agree, sir. Agree, sir.
Huh?
Agree.
Electric shock, huh?
Yeah.
Because guys, I was hoping from when I was going through with the lecture, whenever I ask you question, I mean, many of you don't really ask except for that one guy there, Yan Wei. Okay, so I wanted to really see what exactly are you guys are up to. So that's why I put up this question. And of course, I also tested myself. Can I do this within the stipulated time? So I managed to do this within, both question around 15 minutes. Okay, so then I decided to give you the timing for you, which is about 40 minutes. Okay, so that's how we are doing the calculation lah. Okay, now guys, I think your friend there again, Ng Yan Wei, he told me many of you don't get it, and then how to draw the current direction and so on and so forth. Guys, doesn't matter how the circus looks like, the concept will always remain the same. The concept will always remain the same. Example, this is the quiz one, question number 1. Let's go through this together. Determine the Vx, the given impedance circuit. Okay, the Vx is on the resistor 5 ohm. Okay, what do? First, you have to decide what kind of analysis that you want to use. Is it mesh analysis or nodal analysis? Either way, you will get the same answer. Either way, you will get the same answer. You should be getting the same answer. Okay, now let's look at the mesh analysis. Let's say some of you, okay, I want to use mesh analysis. Okay, so this will be your first mesh, okay. 1 and 2. Okay, now if you do the mesh analysis approach over here, you may find one, I would say, some critical point over here. So if this is my current I, let's say I just label I X. Oh man, the writing so bad. I X. So what is my I X?
It's the first mesh minus the second mesh current.
Okay, I1 minus
I2.
I2. Okay. So in this case, you need to find your I1 and I2 before you get your IX, right? And then multiply with 5 ohm. So it's a bit of a inconvenient for you. You can perfectly solve this problem by using the mesh analysis, but you just have to understood this relationship. Okay, you have to understood this relationship. Okay, now what about if you decided to use let's say nodal analysis? Okay, so this will be your first node and this will be your second node. So, and then you can draw the current. Let's say this is I1, this is I2. Okay, this is I source because you already have the current. And let's say this is your I3. Okay, so now for your node number A, let's say I put A, and this is node B. So node A is I1 equivalent to Ix plus I2. You see, you are getting back the same mesh analysis. And then for your node B, it will be what? I2 plus Is equivalent to I3. Now, what is your Ix? Vx over 5. See, now this is a little bit more straightforward. You don't have to find the current and then multiply with your resistance. You can straight away get your voltage. So what is I1? So I1 will be this voltage here, 40, 30 degree, okay, angle, minus Vx over J5 equivalent to, what is Ix? Vx very bad lah, sorry about that. Vx over 5 plus your I2 is what? Vx minus Vb, you can put it as a Vb. Vx minus Vb over 10 minus J4. Okay, and then now you do the same thing over here for your I2 plus Is equals to I3. Now you have two equations for two unknowns. What are the two unknowns? The Vx and the Vb. So what you have to do now is once you got the two equations, you need to get what is Vb in the function of Vx. And then you substitute, you will get the value for your Vx. Okay? Maybe later I can share you the steps lah. Okay, I'm still marking your quiz. So later, once I'm done with it, I can share the methods. I mean the step that I've used to solve the problem. But this is the initial phase that you need to get it right. Okay, this one. And then this one. This equation must be correct. 1 and 2. Okay, you have two equations for two unknowns. Vx here, and then the Vb here. And then you can solve. Of course, you have to solve very carefully. I can show you mine, how I did it, so that you can have some kind of basic understanding how it was being done. Okay, any question on this?
Let's say for this question, if we were to use mesh analysis, does that mean we only have to analyze the first and second mesh? The third one at the end we don't?
The third one, it's good that you ask. The third one, you already have the current.
But since we're just trying to find Vx, like let's say there was no current, so like, let's say it was a slightly different question.
Yeah.
But just involve on, yep, so you just have to, oh, okay.
Yes, only this one. But then automatically this current will be combined over here.
I see.
Yeah, because what will be the current I3 over here? I2 minus
I3.
I3. This one, this I. If let's say I put this as a IY, okay, just to make the distinction. So when you move up all the way, you reach over here. So this current here will be I2 minus I3 lah. Let's say if this is your I3. And what is your I3? negative 6 ampere, because this is opposite. Okay, so this current will be automatically coming up over here. So you will still have two equations for two unknowns, but then the two unknowns here will be the current instead of the voltage. I ask you for the voltage, so it is better for you to do the nodal analysis because you will get the Vx automatically. You don't have to find the current first and then find the Vx. For nodal analysis, the Vx will be automatically come up. So that's how you seek the balance lah. So that's the difference between the question 1 and question 2. Okay, question 2, you can perfectly use your nodal analysis again. Okay, but let's see what happens if you do the nodal analysis.
There's only one node, right?
Just one node. Okay, if you do the nodal analysis, let's say this is I0, this is I2, let's say this is I1. So you have I0 equivalent to I2 plus I1. But then the issue will be when you develop this. What is your I0? 25. Do you have any phase angle? 0. So it is 25. 25 minus, let's say this is your node 1. Okay, node 1. So minus V1 over 2 kilo equivalent to I2 is V1 over, okay, now you have to change this to reactance. So this will be your omega. This is your omega. 4 times 10 to the power of 3 multiplied with 0.25. You will get J 6.28 kilo ohm plus I1. What I'm doing? V1, I2. Okay, I2 is V1 minus 10 I0 over this one. You have to change to reactance. You will get negative J 19.9 ohm. Okay, you see now you still have two unknowns, V1 and I0, if you do the nodal analysis. So I mean, if you after this you try to solve all of this, it will get more complicated lah. Because what is I0 here? I0 is 25 minus V1 over 2K. So you need to also substitute that value. So the best way to go about is through mesh. So in this case, I mean, a more simpler way of doing this is through mesh. Now, I only discovered this when I tried this myself. You see, I do the questions, and then I try. From the onset, I didn't know I'm having a problem over here. Then I immediately change to mesh analysis. Then it becomes a bit more easier lah. What I'm trying to do is to avoid the complexity. So that's what I want you to embrace. So that's the lesson to be taken from these two questions for your quizzes. There must be always a lesson to be learned. Lesson to be learned here is to be ready. Second, to understand which one is more suitable. Okay, based from your initial analysis. Again, I say you have to be careful. Of course, by all means, you can use either nodal or mesh for both questions. No problem. You can solve it. It's just it be a bit more complex for question 2 to use nodal analysis, and for your question 1, mesh analysis will be complex. Easier nodal analysis for your question number 1, for question number 2, mesh analysis. Okay? So later I can share with you on the step that I have done, so that you can at least can go through lah. So these are the two things that I would like you to do. My part lah. First is your forum. I will create the forum. Second, I will share you the answer for your quiz 1. Okay. Now, any question for these circuits?
Hello, sir.
Yeah.
So, you see the equation you wrote on the paper, right? And then there's V1 minus 10 IO. That is for I1, right?
I1. This one you saying?
No. There's on top right side.
Okay.
Okay, the second equation. Then V1 minus 10 IO over negative J 19.9. So, this is for
I2.
That's I2.
I2.
This is
Okay.
I1.
All right. Thank you, sir.
Okay. It's just
Sir,
the location.
may I ask why you minus?
Why I minus? Because you
Yeah.
have the voltage source over here.
Okay. So we should minus. Oh, okay.
Similar,
I see, I understand.
same thing over here. Like from here to here, so 25 minus V1. Now it's other way around. Since my I2 direction is from V1 to 10 I naught, so that will be V1 minus 10 I naught.
I see. Okay.
You understand?
Okay, sir. Yeah.
I think it's
understood.
because of voltage drop, right? Over impedance.
Yeah. If let's say I draw my I2 in this direction, then it will be 10 I naught
Minus
minus
V1.
1. But then this equation will be different lah. This will be I naught plus I2 equivalent to I1. So that's why your first step is always important. What equation you are showing to me? Then from there, I will analyze all of your working step. If you put this equation, but then when you develop this is actually follows this one, then it will be wrong lah. Whatever that you establish first, it must follow. The rest must follow it. You understand?
Yes, sir. Understood.
Okay.
Thank you.
It's actually very much straightforward. You just have to get the nodal analysis or the mesh analysis correct. Your first equation. The rest, it should come easy. The rest, you will feel difficult because all of this R, L, and the C. But this is something that you guys have to deal for electrical power machine, because we won't deal with pure resistive circuit, but we will deal with the impedance circuit, which consists of R, L, and C. So that's the main point of your electrical power and machines. You won't get motors or generators or transformers that will be purely resistive. Okay, it will be impedance based. So I have a responsibility to actually show you the real circuits. Okay, because at the end of the day, the main issue or the main target is you guys are going to be engineers. You understand? Huh? So that's the our top priority for now. Any question, guys?
So,
Hello?
so when you show the step for this quiz, will it be both analysis or will it be only one? Like for example, in question 1, you suggest us to do the nodal analysis, but will you show the step for mesh analysis.
Okay, the one that I will show is the mesh analysis.
Okay.
Okay, the node analysis, I can leave it to you lah. You can try to do, and then maybe try to obtain the same answer.
Okay. Thank you, sir.
Okay, and then for this, I will show you the nodal analysis. You may try mesh analysis and then see whether you got the same answer. Okay, so this is how you develop more question by your own lah. One same question, you take two approaches, and that's how you become good in solving any given circus. And then I can say that to you, this similar looking circle will come back in your test one. So quiz one is like a precursor for your test one. Okay, and test one also will have those three phase circle. And lastly, guys, we will have class on this coming Thursday, which I have to cover the power in the AC circuits. So please come, please come. It's a very important topic. I would like to see you on this Thursday at 8 a.m. Okay, with that, we can end our lecture for now. Ensure. Okay. Anything else, guys? All okay? Then with that,
Yes.
we can adjourn our meeting for today. Okay. So as usual, always stay safe and stay healthy. Yeah. Will we have a request for this? Request, yes. I will decide later because you see, the time is the one that it is against us. I will check when the possible time we could have the request, if we have it. Okay, probably it won't be a request, but just like to top up your first quiz. But it depends. Let me decide later. Okay.
All right, sir. We'll
Okay.
update you the times we are free to.
Okay. Please get ready. Group 1 to 8 for today's lab at 2 p.m. and group 9 to how many group? Group 1 to lupa. Group 1 to 6, 2 p.m. and group 7 to 12, 4 p.m. today. Okay.
All right, sir.
Thank you very much,
Okay.
Doctor.
Okay, thank you. Okay, guys, see you then.
Thank you, sir.
Okay, you're most welcome.